Hello everyone, thank you for signing into my stream. I'm Mr. Matt and this is Dr. Tot. This is Geometry, the live stream for Lesson 1. So today we're going to talk about patterns and inductive reasoning. Let me share my screen with you. So first I want to just talk about a few concepts in mathematics and far-reaching mathematics as well. I mean, this goes into many, this is multidisciplinary really. But the difference between qualitative and quantitative information. So when we talk about things qualitatively, we're using words, observations, descriptors, modifiers, adjectives, adverbs to describe how something does something or what something looks like. Trying to parse out the description of what we are perceiving at that moment. So qualitative descriptions or qualitative information are descriptions. Qualitative information is of descriptions or takes the form of descriptions, whereas quantitative information has to do with numbers. So let's list this out. Qualitative, it's kind of big. Let's see. We're talking about descriptions. In other words, words. With quantitative information, we're talking about amounts. Or in other words, we're using numbers. And the application of quantitative analysis or interpreting or trying to understand what number data is telling us allows us for more explicit tracking and calculations of exact relationships, whereas descriptors are less exact. Maybe this car is fast and this second car is faster than the first, but by how much and by exactly how do we know that? So a speedometer would be a quantitative approach to analyzing how fast or how much faster one car is going to the other, whereas a lay observer on the side of the road would only be able to describe the two in relative form. It wouldn't be, and then if you introduce a third object, maybe not even occurring at the same time, it would be very hard to measure which was the fastest out of all three, unless you had some type of quantitative basis for it. Okay, so when we say qualitative, we're really talking about descriptors, words, observations. When we're talking about quantitative, we're talking about amounts, calculations, numbers, explicit values. This leads into a more general form of knowledge, and I wanted to take a few moments to talk about the difference in the meaning of the words subjective versus objective. And it goes hand in hand, kind of. They're related. They're not exactly synonyms of each other, but subjectivity is open to influence or partiality of the individual. So subjective natures or subjective fields of study can be open to the interpretation of the reader, the viewer. So art, for example, art is highly subjective because meaning lies in the eye of the beholder. Right? What you think is beautiful art may not be what other people think is beautiful art. People have tastes and preferences that make up their individual likings, right? Or their basis of liking things. Objective nature, however, is relative to fact and truth. So objective natures have to be uniform or as close to uniform as possible. So universal understandings. X is either 2 or X is not 2. Gravity always applies downward towards the center of the Earth. These are objective measures. They're concerned with the absolute truth of the nature of the circumstance, and so we can use those in our understanding between inductive and deductive reasoning. So let me write that down here. So subjective is really a personal basis, or I should say an interpretation. Objective knowledge has a universal nature. And it's really looking towards data, looking towards universal truth that can be applied no matter the experimenter and no matter the context of the experiment. Whereas a subjective, for example, a film, you might react to a specific work of art like a film one way at one point in your life, but very differently at another point because you're going through different things. That's the subjective nature of art. Whereas mathematics, science, they tend to be, or they are examples of objective fields of study. Okay, so that leads us to the main vocab words we're going to be talking about, and that's inductive versus deductive reasoning. So inductive reasoning is using observation. It's a bottom-up approach. And so you might be recognizing that every Wednesday your neighbor leaves his house at 1 o'clock. So that is an inductive observation that you could then maybe apply that he has something to do every week at 1 o'clock. That would be a reasonable assumption if that were to continue habitually to occur. So that's using a consistent observable pattern from the bottom, observing up to making a rule. Deductive reasoning is the opposite of that. Deductive reasoning is applying rules and knowledge or conclusions from previously held observations or experiments and applying them to a certain situation. Okay, so if in a particular theme park, let's say all roller coasters must be blue, therefore if it's a roller coaster, it must be blue. So there's a rule that you're applying that the theme park only has blue roller coasters, and so if you come across a roller coaster in this theme park, you can make the conclusion, unless, based on the rule, that it's probably in all likelihood a blue roller coaster. So that's just a random example, but you can see the bottom-up approach from inductive reasoning, making an observation, seeing a pattern, and creating a rule that abides by that pattern, or deductive reasoning, which is you have a rule, you have a situation, apply the rule to the situation to make the conclusion. Okay, so inductive, is based on observations, and it's a bottom-up approach. Okay, you have to look at all the different circumstances that's going on, generalize a rule, apply the rule to the next circumstance. Deductive reasoning is the application of previously held rules to a new scenario. And this represents a top-down approach. Actually, all of these, the semicolons here are actually inappropriate, so I'm going to use a dash. This is a top-down approach. Okay, if there are any questions, please let me know. Otherwise, get this out of here. This guy shouldn't be here. Let's take a look at a few examples. I'm going to give you 2 minutes. I'd like you to use inductive reasoning to identify a pattern in the following qualitative data, and then make suggestions about the next, about 3 possible next terms. Okay, so there's no right or wrong answer as long as it's inside the system of the pattern. Okay, so I'm not looking necessarily, that's just a hint. The order may not matter here. It might not be sequentially ordered in some way, but try to use your observations to determine a pattern, apply that pattern into the context of the question, and come up with the next 3 possible terms. Okay, I'll give you 2 minutes. Excuse me, 3 minutes. Okay, looking at this first pattern, we have blue, 8, 3, red, 4, 1, yellow. So you can see blue is a color. First, at the heart of this is really categorizing or attempting to categorize the terms into 1 or more groups, or specifically 2 or more groups, I should say. So blue is a color, obviously. And then 8 is a number. So we have these combinations we have a color, number, number, color, number, number, color. So you can start to see the pattern that's developing here. And so it doesn't look like this is in any particular order. Notice how the numbers are kind of randomly placed. They're not sequential at all. So it looks like order doesn't matter here. So we could come up with any numbers at all. So we could maybe have 7, 9, and then gray. But as long as you have 2 numbers and a color, then you did that absolutely correctly. So this is rather subjective. You could have picked any 2 numbers and then any color at the end. They also didn't tell you that these can't repeat, right? So you could have used blue, you could have used red, you could have used 8, you could have used 3. There were no rules here that we could indicate, we could see. The second one, we have red, red, 3, blue, blue, 6, green, green. So what's going on here? Now we have, oops, now we have a color, comma, a color. Notice it's the same color too. It's not red then blue or yellow then green. It's red, red, 3. So then we have a number. Then we have blue, blue, but it's the same color again. Then we have a number, and then we have green, green. So now these colors, we're adding an extra criteria into our sequencing restriction where the colors have to be the same. So it's double colors, color, color, but the same color, some number, same color, a new color but repeated twice, another number, and then a new color repeated twice. So if we wanted to think of some other terms here, again, the order doesn't look like it matters at all. We went from 3 to 6, so we just need another number. I'm going to say 5, and then let me say yellow, yellow. So it could have been any number and any color, but the last color should be repeated twice, depending on this, as is noted in the pattern or observed in the pattern. If you have any questions, please let me know in the chat function. Otherwise, let's look at these two. I'm going to give you 3 minutes. Okay, so looking at this first pattern, we have yellow 5, 2, blue 3, 9, orange 4. So yellow is obviously a color. So we have a color, number, number, color, number, number, color, number. So our next three terms, we have to have a number, then a color, and then a number. So for example, we could have 7, comma, pink, comma, 4. But it could have been any combination as long as you have a number and then a color and then another number. Okay, if you have any questions, please let me know. The second example here, we have purple, red, yellow, dog, yellow, blue, red, lizard, blue, yellow. So we got, what's going on here? We got a color, 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 right? Purple, red, yellow, all three are colors. Then we have dog. We have an animal. Then we have three colors again, yellow, blue, and red. Then we have lizard, that's another animal. And then we have another color. So we would suspect that this pattern would continue, and so our next three terms would have to be two more colors and then an animal. So we could, for example, have 5, 3, bird. And again, that could be anything. Those are just examples. So you could fill those in as long as it followed the system of color, 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 animal. Okay, if you have any questions, please let me know. Oh, I'm sorry, my slide cut off. 1 second, let me get my next problem here. Oh no, my slide's cut off. I'm so sorry, guys. Let me see. These are the ones. Oops. Okay, so I want to take a look at these guys. So now you want to pay close attention to whether order matters or not. Okay, so I'm going to give you 5 minutes. I'd like you to look at numbers 1 through 4. And then I'll give you some hints, probably about 2 more minutes, and then we'll go through the answers. Okay, so let's take a look at these problems. For number one, we have a series A, F, 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 E, C, 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 O, H. So how can we categorize these different letters? So notice that A, E, and O are vowels, but F, C, and H are all consonants. So what we have here is a consonant, vowel, vowel, vowel pattern. So we end on a consonant, so we're going to pick up with 3 vowels. So for example, we could have, and it doesn't look like the order matters. We do go from the first vowel in the alphabet to the second vowel, but then we skip over I here. So it doesn't look like it's following any specific ordination pattern or any type of order, any type of ordination. So we could just pick any vowel here. I'm going to pick U. So maybe U, comma, U, comma, U would be your answer for number 1. It could have been any vowel though, so as long as you have 3 vowels, you're fine. Number 2, we have E, A, G, G, A, I, D, J, O, A. So now we have a vowel, vowel, consonant, consonant combination. So we're ending, and so this is going to continue up to vowel, vowel. So we need 2 consonants and then a vowel, so maybe C, comma, C, comma, E might be your answer, but it could have been any 2 consonants followed by any vowel. For the third one, we have a vowel, A, B, 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 vowel, C, 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 vowel, D. Notice how now all of the things are in order. We have the first vowel followed by the first consonant 3 times. Then the second vowel, E, followed by the second consonant 3 times. Followed by the third vowel, I, followed by the third consonant, D. So if we're looking for the next 3 terms in this series, then we need D, D, and the next vowel after I would be O. So this, because the order matters, this could not be anything else. You would need D, D, O. And for 4, so now we have A, B, B, C, 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 D, 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 D. So now it looks like all of the letters are just following each other. It's not necessarily a vowel-consonant combination. We just have the first letter listed 1 time, the second letter in the alphabet listed 2 times, the third letter listed 3 times, the fourth letter listed 4 times. So then we would list the 5th letter, E, 5 times, but they only ask us for the next 3 terms. So this would have to be E, comma, E, comma, E. If there are any questions on that, then please let me know. Otherwise, let's turn our attention to some quantitative data. And I would like to take a look at these 4 problems that I need to get ready for you. Okay, I'm going to give you 3 minutes. I'd like you to use inductive reasoning to identify a pattern in the following quantitative data. Excuse me, there's a typo here. This is not how you spell quantitative. My apologies. So use the inductive reasoning to identify a pattern in the following quantitative data and then make suggestions about 3 possible next terms. So what did we do when we had qualitative data? We kind of had to section, try to identify or categorize the terms in a particular genre or a particular category, right? Like animal, number, vowel, consonant. Now, with the introduction of quantitative values, you can look for the difference or the change from one value to another. Notice going from blue to red is not quantitatively measurable unless you're talking about measuring, getting a color spectrometer and trying to identify the wavelengths that are bouncing off the different objects you're studying. That would be a quantitative approach, but usually we're not going to, unless you have some very sophisticated equipment, you're going to have to go off of a qualitative analysis of color. And so going from red to blue, there's no numerical analysis or conclusion that we can draw from that change. However, to go from 2 to 6 is a change of 4. To go from 6 to 10 is also a change of 4. So look at the differences between the numbers and see if you can identify a pattern in a consistent manner of change. Okay, so that's my hint for you. This will be the last activity we do for today, and then we'll pick back up on in Wednesday's session with the remainder, with some more activities involving this topic. Okay, so I'm going to give you 5 minutes. Please look at 1 through 4. Then we'll discuss, and then that'll conclude today's lesson. Okay, so if we look at these values, let's take the first set here. We have 2, 4, 6, 8, and 10. So before, we were only able to qualitatively describe the colors or list the colors out in some type of category, try and differentiate them from another term in a label, right, in a generalization. Here we have actual numbers, so what we can do is take the difference between the two. Notice that this is plus 2 more. To go from the first to second term, I add 2. Same thing is true here. 6 minus 4 is 2, in the same way as 4 minus 2 is 2. So notice here, 8 minus 6, that's a difference of 2. 10 minus 8, that's also a difference of 2. So the rule here that you can develop is add 2 to the preceding term. So the next 3 terms would be 10 plus 2, which would be 12, 12 plus 2, which would be 14, and 14 plus 2, which would be 16. So the next 3 terms should be 12, 14, and 16. If you have any questions, please let me know. Looking at number 2, we have 2, 6, 10, 14, and 18. 18. Again, looking at subtracting these values, 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4. 18 minus 14 is 4. There is a plus 4 rule that's going on. So the next 3 numbers would be 18 plus 4, which would be 22, 24 plus 4, which would be 26, and 26 plus 4, which would be 30. For list number 3, we have 3, 6, 9, 12, and 15. Again, 6 minus 3 is 3. To go from 6 to 9, or 9 minus 6, is also 3. To go from 9 to 12, or in other words, 12 minus 9, is also 3. And then likewise, 15 minus 12, or in order to go from 12 to 15, we need to add 3. So the next 3 terms could be 15 plus 3, which would be 18, 18 plus 3, which would be 21, and 21 plus 3, which would be 24. And last but not least, we have 4. We have negative 8, 0, 8, 16, and 24. So it doesn't matter that we start off with a negative term. That's absolutely fine. Notice that 0 minus 8, to go for 0 minus negative 8, that's kind of tricky. But it's 0 minus a negative 8 would actually be positive 8 because you have that double negative there. You can do leave, change, change. That's the same thing as leaving the sign of 0 alone, even though 0 doesn't really have a sign. It's neither positive nor negative. But leave the first value alone, change the operation, change the sign of the second number. And so you see that to go from negative 8 to 0 is a change of plus 8. To go from 0 to positive 8 is a change of plus 8. To go from 8 to 16 is a change of plus 8. And finally, to go from 16 to 24 is a change of plus 8. So the next 3 values could be, or would be, 24 plus 8, which is 32, 32 plus 8, which is 40, and 40 plus 8, which is 48. Okay, so that takes us up to the end of class today. Let me increase my camera here. I'd like to thank you guys very much for signing in and watching this stream. Remember that this stream corresponds to the guided lecture, independent practice problems, and the learning partner activity that will all be posted on YouTube. So please take a look at that. If you found this video useful, please like, favorite, and subscribe. And if you have any questions, then list them in the comments below. I'm also available at on all of my social media accounts, which I'll link in the description. But otherwise, I hope you all have a wonderful night, and I'll talk to you all on Wednesday for the next math session. Tomorrow is reading. So have a good night. Thank you, guys.